Hello again. In this video, we're going to continue with section 2.1, and we're going to start with exercise 4. Albuquerque boasts one of the largest aerial trams in the world, transporting people up to Sandia Peak. In the Sandia Mountains, the temperature at higher elevation is lower than the temperature at the base. The temperature, T, in degrees Fahrenheit, at an elevation h feet above the sea level is, and they give a formula. So again, T is in degrees Fahrenheit, H is feet above sea level. What does the 62 tell you about the temperature and elevation? So let's go ahead and do this together. 62, if you remember, the book uses y equals b plus mt, but you can use y equals mx plus b is the b. So we know that the b is 62, which is the initial amount. And since T is a temperature, it's the initial temperature. That makes sense, because if I plug in H is 0, I do get 62. Or if you want to say it more fancy, we know that the temperature is 62 degrees at sea level. When H is 0, we know that means sea level. Okay, what about part B? What does negative 0.003 tell you? This number. If you remember, that is in front of the variable. That is the m, which is the rate of change, or as we're going to see in the next example, the slope. And if you remember, the rate of change, which is called m, is the change of y over the change of x, and the y, or in this case, the change of t, the y is the t, and the x is the h. This is in degrees, so this would be a degree here, and the h is in feet, so this would be like saying 1 feet. So, if you want to be more fancy, we know that this means that the temperature is decreasing by 0.003 degrees. This little symbol means degrees, or you could just write it, for every 1 foot rise in elevation, since the delta x is the elevation. Again, this is the temperature, and the denominator is the elevation. Or if you wanted to be fancy, this is the tenths place, this is the hundredths, this is the thousandths, so this means negative 3 over 1,000. So that means every 100 feet rise in elevation, the temperature decreases by 3 degrees. So that's how you would do exercise 4. So let's continue on the next page. What does this rate of change look like on a graph? To answer that, let's go ahead and look at example 1. It says to plug in values of x to graph these functions. So I'm going to make a table down here, maybe make this a little smaller, and I'm going to plug in some values. So let's plug in 0, maybe 1, and 2. So if I plug in 0 here, we get 100. Plug in 1, we get 125. Plug in 2, we get 150. And I can plot those points. Let's label these as what? Maybe. So I'm going to go ahead and count by 50. You could do whatever you want there. But 0 we know is 100. 1 we know is 125, so it's halfway in between. 2 is 150. That's not 150. That's better, because I know it's a line. If you get a ruler, let me see if I can try that a little better. If you get a ruler, you can get a nice looking line out of that. Okay, let's go ahead. I know they didn't ask for this, but let's go ahead and look at the rate of change here, the m. The m is the change of y over the change of x. And I'm going to call this my y and this my x. I'll call this my y. And I'm going to pick, I'm not going to pick that 125 since it's not right on the grid. I'm going to pick in red this one and this one, these two, just to show you. So I'm going to do, it's going to be 150 minus 100 all over 2 minus 0. So it looks like 50 over 2, which is 25. This is all part A. So if I rise up by 50, that's this bit, and then I run over 2, this is my rise, and this is my run, that would be what this represents. And you can see, if you have a line, I've mentioned this before, I bet this point is right here, because if you do it again, rise up 50, run 2, you should not get a curve. Now, if you rose up, right, 100 and went over 2, then it would end up being a curve. But since, and I know this doesn't look like a line, but we can fix that. But since this is a line, the slope is what we're going to call it, or that rate of change will be the same. Notice how this rate of change, this 25, is right here on the graph. And by the way, this right here is the initial. So m is the 25, which is the rate of change. It's the slope we're going to see. B is the 100, and it's the initial amount. And notice how the initial amount is the y-intercept. So I can call that, instead of the initial amount here, I'm going to call this the y-intercept. Call it the y-intercept. We'll see it down below, but that's what that is. The rate of change is the same as slope, and the y-intercept is the same as the slope. The rate of change is the same as slope. Okay, if we do the same here, this tells me that if I count to 6, 1, 2, 3, 4, 5, 6, it better be the initial amount. B better be 6. This is all part of this one. And we can go back to blue. And m is negative 0.5, which, by the way, is negative 1 over 2. So 6. So we can actually, going to see that we can use this to actually graph it, because I know that the y, this is the y-intercept. I know this is the slope. So from this point, I can go 6 is y-intercept, and then I can go down 1, do my right, down 1, and run 2. I can think of my slope as rise over run, and then do it again, because I know it's a line. I'm going to try to draw a line there without a ruler, and you get, can erase these little scratch marks, and you get a nice graph. That does make sense. Let's just try it here. Plug it in, oh, that's a T. Plug it in a 0, we do get 6. Plug it in a 2, for instance, that would be 6 minus 0.5 times 2, which is 6 minus 1, which is 5. So plug in a 2, oh, I do get 5. You can see it does work. So here's the formula. It's called the slope-intercept form, because that's where it gives you. You can use their formula, or if you've seen y equals mx plus b, if you're using y's and x's, you can use that. B is the y-intercept, aka we saw before was the initial value. It's when f of 0 equals b. M is now the slope, aka the rate of change, and it's the amount it increases or decreases when the change in time or the change in x goes up by 1. So let's look at example 2. Find the lines that have the same slope. Which two lines have the same slope? Well, they have to have the same rise and the same, should talk about there. M is the rise, the delta y over delta x, which is the rise over the run. Or you can call it delta y over delta t if you're using delta t's. So which two have that same rise and same run? It would be the same steepness. So 1 and 2 have the same steepness. Which one has the same vertical intercept? The same vertical intercept means the same y-intercept in this case, because the vertical line is the y, and it would be those two. So it looks like it would be 5 and 4. So I'll say, we'll just put the y here. Y, this means y-intercept. We said the answer was 4 and 5. Which one has 0 slope? 0 slope would mean no rise. It'd mean like you would not be going uphill or downhill, right? You wouldn't have any steepness. We haven't talked about positive slope or negative slope yet, but 3 is something with 0 slope. Positive slope is when you're walking left to right uphill. So 1 and 2, for instance, were positive slope. So the negative slope is when you're going downhill. So again, 4 and 5 are the two that are negative slope. With negative vertical intercept, again, this means the y-intercept. The one that has a negative vertical intercept, here's the x-axis. So something that's below that would be, looks like 2. 2 has a negative vertical intercept. So let's move on to the next page. So you should be ready to try now. So try on your own, exercise 5. Come back when you're ready. It says that the cost, C dollars, of hiring a repairman for H hours is given by this formula. C is equal to 50 plus 25H. What does the repairman charge to walk in the door? What is his hourly rate? Go ahead, try this, and come back when you're ready. Okay, here's the answers. The answer to part A, what he charges in the door, would be $50. And what is his hourly rate? It's $25 per hour. So the C-intercept instead of the Y-intercept, I'm calling it C, or the initial amount, you can call it, is 50. And since C is in dollars, it's $50. Part B, the hourly rate. We know the slope or the hourly rate is in front of the variable is the 25, and that rate would be in dollars per hour, since M is the change of Y, in this case C, the change of X, in this case H. So this would be 25 over 1, and this would be dollar, and this would be hours. And that's the M. And by the way, this one I should have said since B equals 50. So we use the M and the B as well. And here's the solution to exercise 6. It asks to find a linear function for the passenger height h after t minutes of starting a ride, where the beginning elevation is this, and 1 minute later the passenger is this. So I found the formula by using my mx plus b, where I found the slope and the vertical intercept is given.